The next shape that we're going to take a look at is triangles. And I've given three different kind of types of triangles. And so these are three different looks to a triangle. The first is what we would call a regular acute triangle, okay, as all the angles are acute angles, which you may have seen in the past. The next one is a right angled triangle, which we will take a look at later on when it comes to the side lengths. And the third is an obtuse angled triangle, as it has an angle in here that's bigger than 90 degrees. Again, we'll get into that a little bit later. But if we were to take a look at the number of squares that fit inside of each of these triangles, it might be a little bit tough to see, but you might notice that a bunch of these triangles are like a bunch of these squares are partial squares. And it can be hard to count up partial squares. So like something like this here, we would have this one, this one, this one, this one, this one, this one, this one that are full squares, that one there. And then we have like a really small partial square and a big one, so maybe that could be counted as one, same here, and so on and so forth. And trying to find the number of full squares and partial squares and put them all together can be a bit of a challenge. Now, two measurements are needed in a triangle. The two measurements that we need in a triangle to try to solve for it are the base length, which is going to be our bottom, and the height, which is a perpendicular distance from the bottom to the peak. Now, again, these could be really anywhere in a triangle. It all depends on which measurements that we are given. Now, because a triangle is exactly half of the size of a rectangle with similar base and height, so a base and a height. Okay, so if we were to draw in a rectangle right here, something like this, okay, this triangle is exactly half the size of that rectangle, and so what that means is that the formula for the rectangle is kind of similar to that of, this formula of the triangle is similar to that of a rectangle. So the area of a triangle, and I'm going to do a little TR there, is here, and I'll put in our measurements, base and height, is equal to the base times the height divided by 2. And to write that in a little bit differently here, we're going to do base times height divided by 2, and that's how we're going to list out or find the area of a triangle. Now, I told you we had three different kinds of triangles. An acute triangle like this here, our base is going to be a bottom, which will be given that length, and the height will be from the peak down to the bottom, and this is a perpendicular length. A right angle triangle is a little bit different. Now, we could think of this as being the height and this is the base, but we'll often be given this as the base and this is our height. Now, this is perpendicular from the base to the peak, okay? Even though it's on the outside, it's not on the inside. This is our base, this is going to be the height of a right angle triangle. And an obtuse triangle will often be given this as our height. So that's our height, and then this is going to be our base. So that length right there is our base, this is our height, even though it's on the outside, and we can then find the angle find the area of that triangle. So let's do a little bit of an example, three separate examples that kind of cover those three. In this case here, we have our height and we have our base, and we know the area is equal to base times height divided by 2. So we're going to take our area is equal to our base, which is 7.3 yards, times our height, which is 5.8 yards, and we're going to divide that all by 2. Now, to find our area, again, we can use a calculator, especially with decimals. It can be extremely tough to solve. We do base times height divided by 2, and we get an area of 21.17 yards squared. Now, that is yards squared as it is an area. Now, the reason we have yards squared, and I didn't mention this earlier, but it's yards times yards, and anytime we multiply something by itself, we can do yards squared. So that's where that measure or that unit comes in. A right angle triangle right here should be a little right angle. I forgot to put that in. We have our base on the bottom and our height on the top. So our area, again, is base times height divided by 2. Base is 12 centimeters. Height is 5 centimeters. And we're going to divide that by 2 12 times 5 is 60, divided by 2 is 30 centimeters squared. Well, that one I was able to do without a calculator, but again, just remember that you can always use a calculator when you are solving for the areas. All right, our last one here, this is an obtuse triangle. We have a base here, and this is going to be our height, even though it's on the outside. It's from our base level, perpendicular to the peak. Base 6.1 feet, height 5.4 feet. Divide that by 2, as always. And now we got decimals again, a little tougher with decimals. 6.1 times 5.4 divided by 2. And this is 16.47 feet squared. Feet squared. So that's dealing with triangles. Question 3 deals with triangles. Please take a look at question 3 and solve those questions involving triangles.